Hello everyone, this is Kajal Baghel of SGS ITS College, studying in third year BTech of Information Technology branch. Today we are going to learn about database scheduling, which is a part of DBMS, that is Database Management System. Let's begin. Let us begin by understanding what is a schedule. So, a schedule is a order in which operations of multiple transactions are executed. So, these transactions can be sequence of operations like read, write, commit, or abort. A schedule helps us in managing the execution of transactions. It keeps the record of how these transactions have performed, and it ensures that all asset properties, which are atomicity, consistency, and isolation, must be taken care of. You must know about asset properties, basically atomicity, that all transactions happen or none will. Then we'll talk about consistency. This means that database should be valid before and after the transactions. Isolation, this means transaction does not affect any other execution. Like first transaction does not affect the execution or processing of other transaction. Then come to the durability. Once completed, results will stay even if the system get crashed. Also, the results will stay. These are the asset properties. Now let us know why a schedule is important or critical. So basically, schedule is important because it helps us in managing and maintaining the database consistency and access of shared resources. Now let us understand the types of schedule. So first is serial schedule. So as the name suggests, serial schedule means one after the another, which means once first one transaction will complete, then after another will start. No two transactions will overlap each other. Uh, so so it ensures the isolation, which basically means that it prevents any interference of two transactions with each other. Next type of scheduling which we are talking about is concurrent scheduling. So concurrent scheduling means that multiple transactions execute simultaneously. So concurrent scheduling help us in improving the performance, as it is taking less time than serial scheduling to perform, because simultaneously transactions are performing or executing. This helps in proper utilization of resources. But the main problem or main drawback which happens in concurrent scheduling is that it requires careful management to prevent conflicts, as two transactions can overlap in here. Now coming to serializable schedule, it is the integration of both serial scheduling and concurrent scheduling, and it is like the process happens in concurrent transaction schedule, but the results are like execution of transaction. So it ensures the consistency in the database. So there are two types of serializable schedule. First is conflict serializability, and second is view serializability. Let us look into that. Now let us understand the conflict serializability. So it is a type of serializability where a schedule is considered valid if it can be transformed in the serial schedule we have learned earlier. It is done by swapping the non-conflicting operations with each other. So basically it can be understood in three steps as mentioned here. First is analysis. So basically we analyze the conflicts between the transaction. Then examinations. Then examination means examine read and write operation for conflict. Then validation. So this is done by using a precedence graph. So precedence graph basically determines the schedule validity. Now view serializability. So it is a type of schedule where the final outcome, that is the database state, and the read form relationships are same in serial schedule. Even if the order of operations are different, the final result should be same. So if the final result is same, then it is view serializable. So as written over here, it focus on final results. So it is more permissive than conflict serializability, and allows more complex data, and basically it focuses on achieving the correct final database state, unlike the process. Now coming to the challenges in schedule management. So basically there are three main challenges we face in scheduling management, which are deadlock, waiting, and balancing. So deadlock is a situation where two or more transactions wait for each other to release resources and none transaction can proceed. So for example, there are two resources X and Y and two transactions T1 and T2. If T1 locks X and wait for Y, and T2 locks Y and wait for X, then both resources are stuck, both processes are stuck because none process can proceed and complete. So this is a situation of deadlock. So basically, preventing deadlocks that halt transaction progress. Okay, so next is waiting. So waiting is a situation where we need to wait if required data is logged by another transaction. So it delays in the execution of the transaction and affect the system performance. So minimizing transaction waiting time is the solution. Then third is balancing. So balancing is a challenge to like balancing means it balancing concurrency and consistency. If we allow too much concurrency, then it may cause conflicts and inconsistency. So if there is an inconsistent situation, then it will reduce the performance, and the final goal or the main goal of us is to maximize the throughput without compromising on the correctness of the database. So basically, balancing performance and consistency is the main thing. So coming to the conclusion that the importance of effective scheduling is so performance. So good performance is how efficiently transactions are proceeding. So a good scheduling minimize execution time, waiting, and resource reuse, which end up improving the system throughput. Then concurrency, which means allow multiple transactions to run at same time. It increases systems efficiency. And third and the most important is integrity, which ensure the correctness of data during and after transaction. Basically, it avoids error due to concurrent operations. So I hope you by this video you understand the database scheduling, and thank you.